Lesson 2.2 is about the regions under the normal curve. And today's memory text is found in Exodus 14, verse 27. It says, "So Moses stretched out his hand over the sea, and at daybreak, the sea returned to its normal depth. While the Egyptians were trying to escape from it, the Lord threw them into the sea." At the end of today's lesson, we'll be able to identify the regions under the normal curve. Now, this time, let's try answering. In the chat box, share with me your answer for number 1. The expression 68% is equal to 0.68. True or false? Oh, very good, Noelyn. That's true. Next, number 2. A probability value is a number from 0 and 1. A probability value is a number from 0 and 1. Answers. True or false? We have an answer. True. So how about the others? Remember that if we say probability, it means chance. Example, I'm asking you, how much chance do you have that the other one likes you back? You don't say negative, right? It starts from 0% to 100% chances. That's 1. So the answer is true. So that's from 0 to 1. 0, sure nga wala. 1, it means in percentage 100%, sure na sure, very certain. And between these two, we have the numbers between 0 and 1. Next, number 3. The normal curve is a probability distribution. The normal curve is a probability distribution. What's your answer? True or false? Very good, it's true. Next, number 4. The normal curve is asymmetrical. The normal curve is asymmetrical. It's an answer. Very good, it's false. What must be the correct? If false, modify the statement to make it true. What must be the correct word that we are going to replace? Very good, Erica and Jana. The normal curve is symmetrical. Next, number 5. Under the normal curve, the areas at the tails are minimal. What do you mean by minimal, ma'am? Kakagamay, kakagamay. That one. True or false? Any answers? Under the normal curve, the areas at the tails are minimal. Other answers? Yes, Jewel, correct. That is true. Remember, as I've drawn the normal curve, in the tails, the areas are just small. Number 6, the scores at the baseline of the normal curve are called Z. The scores at the baseline of the normal curve are called Z. Very good. I've seen here Alve, Kiara, and Jana. Yes, it's true. The ones at the bottom, the 0, 1, 2, 3, and the -1, -2, -3, these are called Z, or we say Z scores. Number 7, if mu is 60 and sigma is 5 and x is 70, then the Z score is 1. Okay. Let me draw that so that you can visualize it. The mu is 60, our x is 70, sigma means standard deviation. So for each of the 1, 2, 3, the gap is 5. -1, -2, -3, the gap is 5. If our sigma is 5 and our x is 70, is the z-score at 1? True or false? Other answers, true or false? No other answers? Oh, yes, Alvic Carl said false. Why is it false? What must be the z-score? What must be the z-score? The correct answer is false. So here, remember, our standard deviation is 5. So the next one, it's 65. The next is 70. The next is 75. So if you check, this is for z-score 1 and z-score 2. So under this 0.70, the z-score is 2. Very good. Let's now proceed to our lesson. Now, we have different rules to remember. I should say that to remember, not to memorize, but to remember and understand so that you won't keep on memorizing these rules. First rule, if the two z's are both positive or both negative in values, subtract the areas. But if the two z's have different signs, you need to add the areas instead. Now, what do I mean by that one? For example, let me have my first drawing here. Sorry for my curve. For example, we say, what's the area? If you say z equals 2, that only means this one. 1, 2, this line. Therefore, there's no area being covered by that line. But we say that from 0, if you want to have this area, you need to say, what's the area from z equals 0 to z equals 2? That should be the proper way to say it. Now, how do we do the first rule? For example, we want to check the area from z equals -2 to z equals 2. If you check with your normal curve, you have 0, -2, and +2. The area here is 0.4772. Where did I get it? Check with your z table again. Well, from 0 to -2, that will be another 0.4772. Rule number 1 says that if they have different signs, you need to add the areas from -2 to +2. Therefore, the area of this one plus the area of the other one makes it a total area. So what do we need to do? You need to add them. 4.772 plus 0.4772. That will be the total area from -2 to +2. Let us have more examples. Wait first. Let me first scroll over, okay? Up to rule number 3. I'm sorry. Now here's an illustration to visualize rule number 1. I told you a while ago, from 0 to a specific z value, you just have your table, your z table immediately. But If it's from a negative number to a positive number, area of the first plus area of the second. But if they are the same positive, like for example, this one, from 1 to 2. In your table, you have here from 0 to 1. Then the other is from 0 to 2. So how do we get this one? It will be the area of the bigger one, z equals 2, minus the area of z equals 1. That will leave you with this area. Let's have a specific example for that. Again, your z table with you first. What is the area of the standard normal curve bounded by z equals 0 and z equals 1? Now, the reference is from 0 to 1. Since our reference is at 0, then it means that you just need to have from your z table right away. Based on your z table, let me check if I can have a new share. Sorry. Where's my other one? Wait first. And where's my z table? There. Based on, you could not see this. Can you see my z table? Okay, thank you. So because the reference is from 0, then we have up to 1. So you just need to have your z table. That means it is at 0.3413. Any questions? Now let's go back to our lesson. I'll just share my desktop. Please let me know if you could not see my screen immediately, okay? The second one, what is the area of the standard normal curve bounded by negative 2.34 and 0? The reference is at 0. So what do we need to do? Get your z table right away. That's at 2.34. So 0, 1, 2, 3, 4. The answer is 0.4904. Here, the same. Let's go to example number 3. What is the area of the standard normal curve bounded by z equals 1 and z equals 2.0? Let me start drawing. First is, you need to find the area from 0 to 1. Here. So based on your table, from 0 to 1, this is 0.3413. Next, what is the area from 0 to 2.70? Based on your table, from 0 to 2.70, that will be 4965. Now, they are the same, right? Same positives. So we need to subtract them. We just need this area. So how to solve for this area? The bigger area minus the smaller area. That's 0.4965 minus this one, 0.3413. So the remaining area is 0.1552. Any questions? No questions? Let me go to the next example. Example number 4. What is the area covered from z equals negative 2.43 to 1.81. Here, it's like this one. Let's draw a 0 here. The other is from 0 to negative 2.43. The other is from 0 to 1.81. If you see, based on the drawing, you need to add them. So without memorizing the rule, there are different sides, so you need to add them. First, find the area from 0 to negative 2.43. Based on your table, that's 0.4925. Next, find the area from 0 to 1.81. Based on your Z table, that is 0.4649. So what are we going to do? We need to add the two areas. And the total area is 0.9574. Any questions? No questions? Let's go to the next one. Sorry. Next, what is the area of a standard normal curve bounded by negative 1 to 1? Now, based on your table, the 0 to negative 1 is 0.3413. From 0 to 1, it's 0.3413. So what are we going to do? Negative to positive, we need to add them. The answer is 0.6826. Now in the next one, we'll have rule number 2. Rule number 2 says that let A be the area bounded by the midpoint Z equals 0 and given the positive Z value. If the area is left of a positive value, add 50% or 0.5. If the area is to the right of a positive Z value, then subtract the value of A from 50% or 0.5. Here's how are we going to visualize it. For example, in this normal curve, here's 0. Remember that to the right of 0 is 0.5, right? Half of 1. To the left of 0 is another 0.5. So for example, this is, I have here 1. And we say to the left of 1. How are we going to do it? Remember the total area is 0.5. So if we're going to the right, it means that, I'll have it in vernacular. Kung ang nabilin lang ang imuhang kinahanglan is shade, is i-minus, i-subtract from 0.5. So for example, with the first one, diba, it's only the remaining part. So subtract this area from 0.5. But, for example, ang nabilin muagi pa sa 0. Like it's a negative value, negative 1. Then pag shade to the left, ang nabilin muagi pa siya sa pikas katunga in the other half. Then it means that you need to add 0.5 to your area. Again, if you are just computing for what's left in the half, subtract it from 0.5. But if you're computing with the half, then you need to add the 0.5. Example. Here, find the area to the right of 0.94. If we see to the right of 0.94 is the leftover right of 0.5, this is 0.5. And this is just the leftover. So what do you need to do? Find the area from 0 to 0.94. That will be 0.3264. Since we're only looking for the leftover of the half, then subtract it from 0.5. This one will take the area 0.1736. Any questions? No other questions? Okay. I'll have the next one with you. To the left of 2. In the chat box, share with me. What's the area to the left of 2? What's the area to the left of 2? You see, this one will pass by the other half. So what's the area? What's the area, students? What's the area from 0 to 2? This half. In the chat box, share with me. What's the area from 0 to 2? Okay, I have an answer here. From 0 to 2, it's 0.4772. And it will still pass by the other half, right? The area of the other half is 0.5. So our total area is 0.9772. In some, we call it, what's the area of z less than 2? If you say less than, it means to the left. If you say greater than, like this one, this is z greater than 0.94. That means to the right. Let's go to the next example. Rule number 3. Let A be the area bounded by the midpoint of Z. Actually, this is just the same with rule number 2. And for example, this one, the first one, to the left of Z equals -1. To the left. So it's the leftover of the half, right? So it's the leftover, we subtract it from 0.5. Say 0.5 minus 0.3413. The answer is 0.1587. Ma'am, where did you get 0.3413? That is the area from 0 to -1. That's 0.3413. This is the 0.5. So the leftover, subtract it. Next one. It's the last. To the right. To the right of, sorry, dapat dili pa dalawang no. To the right of -1. From 0 to 1, it is 0.3413. From 0 to positive infinity, what is the area? What's the area from 0 to positive infinity? The area is 0.5. So what we are going to do, to the right, it means Z is greater than -1. So our probability is, you add them, 0.8413. Any questions? Again, let's review the rules that we have. Rule number 3 and number 2 tells you if it's the leftover of the half, subtract. If it's the part plus another half, you add. While rule number 1 tells us that if it's from 0 to a specific number, directly under, right under appendix, table, the Z table. It's from negative to positive, you add their areas. If it's from positive to positive, subtract the areas. Or if it's from negative to negative, you still subtract the areas. Any questions?